Question 28a, Part 1. If Jacob's handful represents a random sample, then the proportion of gold coins in the handful, 4 out of 37, approximates the proportion of gold coins in the jar, which is equivalent to the probability of randomly selecting a gold coin from the jar. 28a, Part 2. The ratio of gold coins sampled, 4, to the total number of gold coins, 20, will be equal to the ratio of the silver coins sampled to the unknown total of silver coins, which I'll let be x. Rearranging this relationship gets x equals 33 multiplied by 20 divided by 4. Or 165. Therefore, the total number of coins is the silver coins, 165, plus the gold coins, 20, so the total is 185. Question 28b. The total cost of buying and running this heater, assuming it is used exactly as labelled, is the purchase price, $990, plus the cost of using it, which is 505 kilowatt hours multiplied by 0.35, the cost per kilowatt hours, multiplied by 5 over 5 years. Giving a total cost of $1,873.75. Question 28c, Part 1. The probability of a win and a draw in any order corresponds to these two branches of the tree diagram. A win, then a draw, or a draw, then a win. As both branches have the probabilities of 0.7 and 0.2, we can multiply these values and then multiply it by 2, as there are two branches. Giving a probability of 0.28. C, Part 2. Paul is incorrect, as probabilities cannot exceed 1. An alternative reason why Paul is incorrect is that the probability of 2 wins would be correctly calculated as 0.7 multiplied by 0.7, which is 0.49, and not 1.4. Question 28d. Margaret's quarterly interest rate will be 3% divided by 4, which is 0.75%. In 6 years, there will be 6 times 4, or 24 quarters. So to calculate the contributions required to reach 75,000, and to multiply that value by the value from the table, 0.0382. Giving us a contribution of $2,865 per quarter. Question 28, Part E, Part 1. The volume of one marshmallow, being a cylinder, is equal to pi multiplied by the radius squared, being 2.5, multiplied by the height of 3. Giving a volume of 58.9 cubic centimetres to 1 decimal place. Question 28E, Part 2. All the chocolate in the cake is contained within this rectangular prism. Based on the dimension of the marshmallows, this prism is 15, 3 marshmallows, by 10, 2 marshmallows, and it is 6 centimetres deep as the marshmallows are 3 centimetres high. This prism has a volume of 15 by 10 by 6. (900 cubic centimetres). But this prism contains 2 layers with the equivalent of 6 marshmallows in each layer, so 12 marshmallows. These 6 can be seen as 1, 2, 3, 4, 5, and lastly, by combining the quarters, 6. The volume of these marshmallows will be equal to the value of the individual marshmallow as calculated previously multiplied by 12. Which equals 707 cubic centimetres. So the volume of the chocolate is equal to 900 minus 707, which is equal to 193 cubic centimetres.